All right, guys, we are live from the Deutz booth, and we are with the engineers. We've got Michael, and we've got Chris. So these guys are going to break down the different kinds of motors, and this is going to be stuff that's way beyond my pay grade, you guys. So I connected with the engineers from Deutz to hopefully explain diesel motors, gasoline motors, hydrogen, which really honestly totally confused me. I've heard hydrogen, I've heard these hydrogen motors are out there. I know nothing about them, but by the time we're done with this, so you guys will be able to explain it. And then we're also going to talk about the battery, which I know you guys probably heard before. But then battery hybrid, and what's the advantages, disadvantages, and how all this stuff works and where things are going from there. Is that kind of the overall game?
That's what we're going to do.
And then at the end of it, we're going to talk about something that I learned that kind of blew me away, which was Deutz actually has the kind of rolling out this limitless warranty program almost. Like a dude that buys a motor now, if he follows the parameters of this program, will have a warranty 10 years, 15 years, 20, 25 years, as long as he stays within the parameters of just some of the things that these Deutz wants to know, how he's treating the motor. Yeah, the way they use it. So, all right, I'm going to take over the camera, and then I'm just going to ask you guys to start breaking this out, because the first thing I want to cover is the modular design of these motors, and then start to understand all of them. So I'm going to go over here, and you guys that are, this is your chance to actually ask. Can't hear you, bro. This is your guys' chance. Very low audio. Okay, I'm going to try to turn this up. Thanks for the feedback. Can you guys hear me now? Very low audio. Can you guys hear me? How's the audio now, you guys? Audio. All right, so this is your guys' chance to ask these guys questions. All right, so where are we starting, Chris and Michael?
I think we should start, Stan, with the separation. Can you hear me now? Is that something okay?
They're hearing fine now. Yep.
So to separate between, you said motor, and we call it engines. And that's, I think, the difference where we separate the content between us two today, Stan, where Michael will explain all around the motors, the electrical motors, and we talk about the engines.
Okay.
So the combustion engines. And what we have here at the Deutz booth here at the 2020 ConExpo, we have a modular concept of our engine portfolio. We have modular concepts between small engines, big engines, gas engines, diesel engines, and a combination where we talk about bi-fuel, where we have a combination of gasoline and LPG, gas too broad. What we do have here, starting out with our 9 to 13.5 liter engines, we have a bigger module or bigger engine, which is an 18 liter engine. This is, the industry knows it as a collaboration with a strong partner out of Europe on this 9 to 18 liter engine. Inline engines, just to talk about it, very strong, very reliable. Within the construction equipment, purely diesel in this configuration as we see them. We, from the Deutz Corporation, so the Americas division of Deutz, deliver these kind of products in a form of power pack. So we are adding value from radiator packages all the way to the flywheel housing, clutches, to hydraulic pump applications at the back end.
So now you guys do something very interesting. This block is running a diesel engine.
Yes.
The block right behind you is running the same block, but now it's hybrid. Yeah. Or no, this is hydrogen.
This is hydrogen, but there's more nuance to it. This engine comes into the same block between the 12 liter and the 13.5. This is the modular concept of this kind of engine. When we talk about the similarities, this engine is a 7.8. 7.8 as a diesel engine. We do have it as a turbocharged engine. We do have it as a twin turbocharged engine. And we have it as this R&D concept over here. And that is exactly, as you rightly said, a hydrogen engine. We maybe have to dive in a little deeper here. This is not hydrogen connection to a fuel cell. This is not a fuel cell. This one is actually the same engine as it is as a diesel engine, now using hydrogen, H2. It uses the hydrogen in the combustion process, so we have NOx in it. but we have an absolutely CO2 neutral type of engine. What we do, if you would come over here to the left, and we marked extra the components in blue for the hydrogen utilization and usage. What this is an EGR cooler. Typically, everybody from your audience knows the external gas recirculation here to reduce the emissions in that entire combustion. This is where
So this is what makes this a hydrogen motor. So you're actually taking a diesel motor,
engine.
a diesel engine,
Yes,
and
sir.
then creating a hydrogen engine using the same block, the same building blocks.
Correct. Same building block, same in terms to some degree. We of course need to talk about pistons right now. We talk about different octane of hydrogen, which is a higher octane here. We talk about complexities on flame front. We talk about a very, let's say, unstable, very coordinated type of combustion in there. But these are details which would have to talk to where the hydrogen engine brings definitely its benefit. There is a downside to it, Stan, which is, for example, the energy per volume. So the diesel brother to it, or a gas, or the diesel version, let's stay with the diesel version, would have a tank in a typical application for that engine, which would be a wheel loader, large wheel loader with a, let's say, 120 liter tank. In that hydrogen version, Stan, it would have to have a 2,300 liter tank. So there are always pros and cons to this kind of technology, and it has to find its niche. So what we believe is that this CO2 neutral, still a reminder of NOx in it, trace, but will have its niche in an application which can be charged, can be tanked overnight. So that's where we definitely will see its niche.
Okay, so what is hydrogen fuel?
Hydrogen fuel in this case is a byproduct actually of the engine which we see over there, in most cases was just the gas engine, and we're using that H2 here in this type of combustion process, and the nitrogen is introduced in it as well during the combustion process. But we end up, let's say that's what I do not want to call it a rumor because it still has NOx in it, that you do have water at the end result of emissions. So a total clean engine.
Okay.
That is a very rough explanation of the combustion process.
Okay, so a hydrogen engine actually burns
the
hydrogen and creates.
And comes in it as well, so you have nitrogen in the process, and with air in it, you do have the advantage that you have neutral hydrocarbons.
Okay.
So CO2 neutral. You still have that trace of NOx in it, and therefore have a very clean engine. The Europe does not. Is that correct? That the European registration does not allow to call it a zero emission. The U.S. government allows it.
Okay, so one of the guys wants to know, where do you get hydrogen from? So if they decide that they are going to now,
Good question.
where did they get it from? And one of the things also that I want to bring up is this is a true hydrogen engine versus some guy.
cell.
Yes. Okay.
Versus a fuel cell, correct. Fuel cell, we know it out of the car industry. In a fuel cell, just a quick excursion to that. Is using the hydrogen and separates the electrons from the hydrogen through a filter and uses the electrons to drive the motors. This is really, as you mentioned earlier, the core block is used in its original construction and is really burning the hydrogen. And where do we get it from is your question. It's a good question. Infrastructure of hydrogen is a question. We know that, as I talked about, the bypass product of the gas, fuel or biomass is another way of how to extract it. But then how do you distribute it to the gas stations? And that is something where definitely an infrastructure is necessary, that it is lucrative for the end customer to fuel up.
So are they actually in the process of building the infrastructure to supply hydrogen to these guys?
It is always the question of demand and support, or supply in this case. And yes, that is something where a lot of power stations, as we see it with electrification, are, as we speak, happening on the hydrogen side. Yes, sir.
What is the average cost for, one of the guys wanted to know, what's the average cost for hydrogen versus diesel versus gas? How does it compare?
You definitely have a cost benefit on the hydrogen versus gasoline versus diesel in buying a liter of it or a gallon of it, definitely. again, the utilization is a question of your equipment because you have not the storage capacity as you, so energy to volume is a different ratio and definitely the downside. It needs to be a niche application.
So one of the good questions is how important is the actual block of the motor, and that's one of the things I actually wanted. Engine. How important is the actual block of the engine in comparison to the rest of it? Because you guys actually have an industrial block, right? I mean, that's...
If we separate block versus head, the block remains the same. So we're talking, the block always is an important structure of the cylindric pressure situation here. That's not what we touch. What we touch here is the combustion process in itself. And hydrogen with its high octane is a very complex, very reactive gas. So what we have to do here is pay attention on the flame front, pay attention on there's an English word for it, which is the ability of the gas to escape between gaps. And hydrogen has a very high escape rate. So valve to head gaps have to be very, very minimal, that you do not end up with backfiring. And these are the elements which you have to have a very coordinated combustion process. So you have to deal with a specific head here where flame fronts have to be able to expand. They cannot be ignited by type of hot spots. At the cylinder, at the valve trains, because then you end up with an uncontrolled type of combustion, which we call in the industry knocking.
Okay, so one of the guys brought up methane versus hydrogen as so we're talking about byproduct fuel sources.
Yeah.
How does hydrogen compare in safety to methane?
In compare of safety, I would have to think about it. Good question. You're catching me off guard, so it's a good thing. So I just know that from an emission standpoint, MH4 I think is the physical abbreviation of methane. So you do have definitely a greenhouse gas here, and there is of course an interest of using greenhouse gases in order to reduce environmental influences in general. This specific, let's call it an adventure at that point in time, is specifically focused on the hydrogen.
Okay, so one of the guys Tyler Bell wants to know what happens in a crash, boom or not? That was his question.
There is no boom. There is boom in the crash, but that might be it might be just a sound. I know that you're talking about functional safety. With Deutz, that is our, first of all, 150 plus years of progress in the entire engine development, right? So we know a lot about booms. So Nikolaus August Otto, when he invented the first gas engine, shot actually pistons through the roof. So boom in this case is functional safety, and that's Deutz's first mission here, to bring products into the market which do not boom.
Okay.
That is a simplified version of the answer.
Well, that was one of the questions that the guys had. And hey, you guys, if you guys have any questions, make sure you ask them, because this is my chance to get together with Chris, with Michael, with the engineers from Deutz and get your questions answered. So what else are we going to be looking at today as we look at these different motors?
I think Stan, engines.
Engines.
It's very important. There's a real term, and Michael maybe will explain at one point in time if you agree with the tour going to the gas engine, from the gas engine towards the small diesel engine behind us, and then we combine at the small diesel engine behind us, which is a hybrid system. It combines the diesel engine now with your motor, and that's where Michael comes into play, into the full electric world. Does that sound good?
That sounds good. And one of the things also I want to talk about is I want to make sure that these guys understand what exactly does the modular design of your engines refer to, because I think this is a relatively important point that we need to understand. Is you guys have configured these engines to make them almost universal. So if an end user decides they want diesel, they can have it and fit in the same compartment. It'll go.
Let's go over there.
What's
on that note?
Okay.
Let's find our colleagues over here.
Okay, hold on.
Yep.
You've got to talk really loud. These guys
Okay.
are asking me to have you speak up.
Okay, I do. I definitely do. Tell me when it's enough. Let's use that gas engine for a modular concept. That modular concept and modular, you will find that word, that meaning in several different forms. And Michael will pick up on the modular concept with the batteries. He will talk about the modularity and scalability of our hybrid system in the back. But in one terminology, one description of modular concept, Stan, is we have here as an example our 2.9 product. 2.9 in this case means actually 2.9 liter combustion engine size. We do offer that version in a natural aspirated, so you guys know it without a turbocharger, or diesel natural aspirated, TD and TCD. That engine in the same configuration in that modular concept now comes as a gas version, and that gas version has two different nuances. It comes as a gasoline version, so what you put into your car at the gas station, or it comes as an LPG version, or it comes as a hybrid between the two.
So also, you said LPG. I want to make sure we cover that. So these guys out of the bottle. So you're the awesome video quality. Okay, good. Thanks, Joe. I'm answering questions. So just so these guys know, sometimes you guys may hear me say something, and these guys are giving me feedback.
Okay.
So good. Thanks, guys, for the feedback. You guys said in the video that their audio wasn't quite right. That's why I'm holding the camera close to these guys so you guys can hear them. If there's anything else you guys want to hear or see, this is your chance to jump in. Now, to get back onto this same motor, this is your gas, this is engine. I'm going to screw that up every time because that's just...
You want me to point it out because I think it's important. This
Yes.
is an engine, and the motor different. There's really a difference in the nomenclature. So if you are an expert, you have an expert crowd, I think we should give them the honor to call them right.
Yeah,
Sure.
no, you're
I
right.
hope I don't bother you.
No, do it.
Good,
Do it.
good.
No, please do. Call me out. I love it when I get called out because I don't know, and I never claim to know everything, and I
do it in
don't ever
return.
want to do it.
Don't do it in return. So the modularity on that stage, exactly the LPG. We had earlier in the week when we all were here to build up this very impressive Con Expo, we had a lot of aerial work platforms, and your audience know probably the aerial work platforms, the man lift quite well. So there is a multitude of job sites for these aerial work platforms. So one of them...
He's talking about the platforms
Yes,
that
sir.
lift
Yes,
up,
sir.
you
To
guys.
lift
Just
up here in the ceilings to get all the wirings done. And one necessity of that aerial work platform is the indoor job site, as we have it here in the ConExpo. So at that point in time, we had one of the strong brands, OEMs, which we collaborate with, have an aerial work platform, which was an LPG version. So it had the bottle on the side, and at that point in time, it had the benefit of no emissions into the environment. So it was actually able to run indoors with a 2.9 actually in that aerial work platform. So in this case, if we would have the biofuel, you would be able to operate that aerial work platform indoors with the benefit of the emissions, as I explained, but you would be able to run it outside, would be able to fill it up with gasoline if there would be any type of advantage to you, because you would have that kind of power source as gasoline on site, and then you have the benefits of both worlds. Be careful with the cost side of it. You might be interested in having either or. It depends all on your user story. If you can narrow that down to indoor use only, you want to go with the LPG version because it has absolutely the benefit of the emissions. And if you want to go for cheap, if you want to go for cost improvement, you go with the gasoline version. And be always careful that these aerial work platforms have a 30% of utilization of the performance, and that's where the hybrid comes in. That's where we go over there and say, hey, we have the advantage of the emission system, we have the efficiency of the cost breakdown for the gasoline version, we have explained the modularity of that 2.9 as an example. If you want, we go over to the hybrid and explain now a different nuance of this kind of modularity.
I want to make this very simple for these guys to understand. When you talk about modularity, we're taking a block and we're able to configure this.
Yeah.
The red part is the block. I said
Black
motor,
one is
but
the
now
head.
I've learned that motors. Oh, wait a minute. One of the guys just said, I've always learned that motors run. Say the comment again. I was reading it and it went fast. motors run on electric engines.
He's correct. He's
Okay,
correct.
okay, so
That's
one
the
of the-
reason why we teach Stan that it is an engine. And Michael will teach Stan what a motor is.
Perfect. So this block allows you to configure it, and we're going to show these guys how they can control the configuration on their own, whether they want diesel, hydrogen, or a hybrid combination of each one. I love that. But you also have this combo on this block system, which can be pure gas, it can be pure LP, or it can be both.
Yeah, gasoline and LPG can be combined. We call it the bi-fuel. It has the same theoretical components and theoretical combustion process to it. It is an ignition system, so not a compression ignition system as we run it on a diesel. So that's the reason why these both systems can be run together.
Okay, so Steve asked, what about natural gas for indoor power sources?
Yeah.
And then another one, is there a loss of horsepower between LP and gas?
That's correct. We do have, it's a good point, we do have a reduced, and we always can show what your steps over there. These different panels over here show all these different nuances where we can click on the technical data to really show the reduction of the, let's say, the power output in kW or horsepower between the different variants. And yes, your audience is correct that we do have a power reduction in the gasoline version or in the bi-fuel version from its original diesel brother. That's correct.
Oh, perfect. So let's talk, what about three? Okay, I don't know. He retracted the message. KW versus HP. Can you guys give me a basic understanding of what that?
It's just a conversion in the unit, and which sticks to everybody. In the US, we're using still horsepower. In Europe, we're using KW. It is very convenient for us in the industry to use KW because it's immediately harmonized to the electrical power output. And your audience might know the emission standard thresholds in 56 kW, 75 horsepower. It's just a unit change. Is one of the thresholds which EPA requires. There's another one above that, and we are running somewhat around the 170, and then there's another one below. It's about below 19.
Torque loss, and how does that compare to diesel?
Absolutely. These engines, this specific one, we have a high torque version which goes even up the 400 Newton meters. You do have typically a torque loss depending on, and then now you talk into gas, cleanness, etc., etc. So in this case, the lowest one was somewhat around 200 Newton meters, and maybe up into 160, and I would have to look it up because of the different variants of the engine. So you're definitely there.
How about in general? Are we saying that there's going to be a torque loss when you go between the options?
That's just because of the BTU between the gas, gasoline, diesel. You run a lesser, let's call it simple, powerful type of medium in which way you can create power in its simplified version.
Expected life on those engines: 10,000 hours, more, less?
Deutz builds engine honestly for last, and we'll talk about the infinity on warranty later on today. But these engines are run and tested through the most stringent type of test cycles in the dynos, in its artificial type of environment, as well as in the field test as the industry is requiring. This is we call it in the specific nomenclature would be a B10T. So it's 10% of its expected lifetime before a total failure happens. That's the industry, how the industry rates the lifetime of the engine. And that would scare you if I would say 6,000 hours. But there's a lot to it which we would have to explain. So these engines run by far above 30,000 hours and beyond.
Two majorly important questions. One is end user maintenance, but before you say end user maintenance, can you say get to the chopper?
Get to the what?
Chopper.
What is that?
Chopper.
Get to the chopper?
Yeah, one of the guys want to say, you just got such a cool accent, you sound like Arnold Schwarzenegger.
Okay.
The guys are like, see if you can, yeah.
I'll be back. Arnold Schwarzenegger, guys. He's a great guy. And I watched him one time, and he was talking about his muscle time at the Gold Gym, and I love the guy. But
Oh, I know, I see that movie,
Yeah.
All right, so now let's get back to end user. let's get to the end user maintenance though. How does that play
I
out?
would love to show you. Can I postpone that kind of question? And I would love to have Marco talking about a very, very cool tool which he will explain later to us with the augmented reality. We do have a digital service app, and he will show you something really deal breaking. Even we have, and I always say that we are responsible for, I always say, from Prudhoe Bay to Patagonia. And you can imagine that in the North American part, we have a lot of dealer, service, network, density, it's all there. If we come to Prudhoe Bay, if we come to Alaska, if we come to the mountains of Patagonia, we don't have it in the density as you are aware, but we are capable of maintaining that service out there, and that's something I think which Marco, as the expert, will talk about, in which way we even do distancing servicing, and that's something which is a deal breaker for the future.
Got a question for you. One of the guys wanted to know about the differences in temperature effect on the motors. Have you guys noticed anything with the different fuel sources?
Good. It's a good engines. Yeah, it's a good point. There's a lot of heat elements, heat distribution between the components. You have a very good audience here. You have a very knowledgeable audience. That's where these components, and we do so much simulations at the beginning on how, and this is the exhaust manifold in this contraction. You have the intake portion right above it. So all these type of heat effects on the components is absolutely something which definitely we are considering, and of course we have to test, because of these higher octanes are burning hotter, absolutely true. And with a combustion ignited, pressure ignited system, and now a spark ignited system, you have to pay attention on exactly these hotspots that you do not have any type of uncontrolled combustion. Absolutely true.
How about a blanket terminology for the differences in fuel efficiency between the fuel options?
You cannot say, because the fuel efficiency by volume, by density, by cost, there are so many elements of this kind of efficiency, and that's the reason why we at Deutz believe that the diesel in its core system will have a future for the next 15 plus years, because there is so much efficiency in its core. But there are further niches then which have their unique selling proposition, as it is the hydrogen engine, as it is the combination of the biofuel versus the gasoline in itself, the hybrid and the electrification, which Michael will explain to us in a minute. All of them will have a unique selling proposition. And if you, and I want example, please allow me that, the scaling of an engine in an application, in a wheel loader is a good example, Stan, where we know that we scale an engine in, let's say a mid-sized wheel loader, 5,000 pound loading capacity. We make the example that the wheel loader now drives into the pile of dirt and lifts the bucket. That's when you do have your max output required. That's when you need, in this kind of stage, your 70 kW, your 105 horses. So now you back up your wheel loader, and now you utilize 30% of that wheel loader. Now the next work cycle of that wheel loader is driving to the next spot and lifting the bucket again and dumping that kind of shovel with the whatever you have into that. So you have a utilization, an average utilization of somewhat 30% of that wheel loader. So now, question, how do you want to scale your most expensive component of that wheel loader? To the user story. That's the answer. And right now with diesel engines, we are scaling it to the max, and you as the end user, the OEM, and we carrying the cost. So now it's really about the time to use all of them for their specific user story, for their specific niches, in order to get that most efficient, coming back to your efficient question, most efficient solution. And I think the hybrid one is the good solution to come to that.
Fantastic answer. Couple guys asked, what's the applications? Now remember, guys, this can go in
everything. Deutz has over 2,500 different applications. While we walk over there, if that's okay for you, 2,500 different applications, 2,500 different applications we apply. Our engines in material handling and aerial work platforms, as well as wheel loaders, dirt moving, are just some areas, construction. Then there is forestry, there's agriculture, there's marine. There's so many different applications where we hit the market in and have the right products for them.
Are you available in Ireland?
I am available in Ireland.
Nah, I mean your motors.
I know.
Okay.
I think so. It's personal. I'm bleeding red. So therefore, yes, we are available in Ireland, and we can ask that question to Marco. Marco, Deutz UK. We have different type of Deutz brands, and of course we are present in the UK and very strongly.
And we are going to get to Marco at the end because we're going to be talking about maintenance. We're going to be talking about all this stuff. Yeah. But at some point, Michael, you're going to take over and talk to us about electric and electric hybrids. Okay, you got to talk loud though. These guys. All right, so where do we start? Guys, this is Michael. And guys, I want to introduce you to Chris. Chris, tell me what you do for Deutz real quick.
I'm the Vice President of Technical Customer Support, including the development. So what we're doing at Deutz Corporation, located in Northwest Atlanta, Georgia. We are taking the Deutz products developed out of the headquarters in Cologne, Germany, North Rhine-Westphalia, not impacted by any type of corona. No, I'm lying. So we're taking that kind of co-product, and we are definitely putting the user story, the American user story, as we said earlier, from Prudhoe Bay to Patagonia to the Deutz product. And one of the results here is what Michael explains to you in a second. That's our D1.2 hybrid.
Okay, so you said Georgia. You guys are located in Georgia. That's where that's where that accent comes from?
No, that accent comes from Ireland.
Okay. All right, so now we've got Michael is going to take over and help us understand the electric motor. And Michael, before we get too far in it, can you tell me what you do for Deutz?
Again, happy to do so. I'm in charge of electrification at Deutz. I'm the Vice President for electrification, and I do that on a global scale. What Deutz did is, apart from what you've already seen in this booth, developing from a pure diesel engine manufacturer, which Deutz has been doing for more than 150 years now, Deutz over the past decade or so has been developing all kinds of alternative, sometimes revolutionizing drive systems. And you've seen the hydrogen, you've seen the LPG, you've seen all the stuff that Chris already explained. And what we've been doing over the past 3 years on top of that is to look into electrification, because as you know from on-road, electrification is a big issue, and with regards to getting greener and with regards to avoiding CO2 emissions and so on and so forth, electrification for somebody who has its core heart in diesel engine is also important.
Okay, so are we going to be looking at pure battery hybrid first, or where are we going to go with this so these guys have an idea?
All of that. So what we can do is to lead over from diesel to electric is we'll have a look at our hybrid application first, and then we'll take a look at our battery. We've got a lithium-ion battery in production, which we are showing in this booth, which we can take a look at.
And audio's good, audience. Audio okay with Michael? Is he loud enough? I want to make sure you guys can hear. So far, I've gotten good feedback. You guys tell me.
I'll stay close to the camera and try to keep it up here.
So now this actual hybrid system is audio's good, so we're good. Perfect. All right. So this hybrid system, which I think is really I didn't know anything about hybrid. I was just kind of always confused. What does hybrid mean? Where are they going with this thing? Can you like really basically break this down for us? And then as you break it down, these guys will have questions. We'll then go to another one.
Yeah, let's take a look then.
All right.
Let's get closer. So if you switch to electric from combustion to electric, the problem is always you need a battery. And the problem with the battery is in the same space, the space the battery takes, if you put diesel into that space, you have a lot more energy and you have a lot more mileage out of that room in your vehicle. So if you switch to electric, mileage is an issue, or time of use. Now, what we're doing with hybrid systems is we're combining the diesel engine or the combustion engine with the electric motor, and that means we can choose either in situations where we're indoors or where we have enough power in the battery left. We use only the electric motor and are emission free and don't create a lot of noise. In situations where we need a lot of speed, where we need a lot of power, where the battery is empty, we switch to the diesel engine, which is louder, which causes exhaust, but which takes us home. Okay?
So one of the things that I want to, what's the usable lifespan on their lithium batteries? How many discharge cycles? That's 2,000. right?
Yeah, the one we're going to look at in a minute is the one we're producing at the moment. Has roughly 2,000 cycles, and so it depends on your use case again. If you use it, if you use a full cycle every day, you've got 2,000 days.
And we'll cover that in greater detail
More
too.
likely is that you don't use a full cycle every day, and then you have something like up to 6 to 8 years or something of useful life for such a battery.
And a real quick question, Michael. On this system, you are developing everything internally. You're not relying on outside sources. You actually have the software you guys have developed, as well as the motors and technology.
It's a great observation you're making there. What Deutz brings along to its customers is experience in diesel for more than 100 years.
Yep.
It brings along their own software, their own production site, their own battery engineering, their own battery management system software engineering. We do produce those batteries in-house.
You produce the batteries in-house.
We assemble the batteries in-house.
Okay.
And we've got all what we need inside the Deutz group to bring along, and we're going to take a look at this one too in a minute, I guess. This is the telehandler, which has a fully electric drive train in it. It's a telehandler from one of our customers, and we put a Deutz fully electric drive system in it, including motors, including battery, and so on and so forth. And everything in that drive system is engineered, developed, and then manufactured within Deutz.
And we're going to talk, these guys want to know about what if they have software problems, all things like that. And this all boils back down to where we're going to end with Marco and talk about the field serviceability and what that actually means and how Deutz has created a program to...
2 points to that. 1 point, like, let's take a look at software issues. If there would be a software issue, the great thing is you would talk to Deutz. You don't have somebody else doing software for Deutz that then is put into your application and you don't know who to talk to and get fussed up. You talk to Deutz because Deutz develops the software, and as Marco is going to explain to you in a minute, Deutz does the maintenance and has an advanced maintenance system, and we're also pretty good in guaranteeing what our systems can do as long as you treat them the way they need to be treated.
Okay, so you were about to show us this
Back to the
motor.
hybrid?
Yes, let's look
Okay,
at this.
So hybrid has the diesel engine. This is a small 1.2 liter diesel engine. It has a clutch. It has the electric motor, and then it has an appliance to it. In this case, a hydraulic pump. So with this application, we can either run on diesel, and then the motor would be turning and would be acting as a generator, and the battery would be charged when the diesel is running, and not all the diesel power is used for the application.
Okay.
We can pull the clutch, switch the engine off, turn it off, and we can use the diesel motor powered from the battery to power our application, whichever application it is. For example, this in size and dimension is made to be put into aerial work platforms. The third thing we can do is, if I have an application that usually needs low power,
Okay.
but sometimes needs peak power, has spikes, yeah, because it goes up a hill or because it digs into, I don't know, into dirt or something like that. If I have peak power situations that I want to cover, but I don't want to have the big diesel engine that only is used to its full horsepower a couple of times a day or so, I can use this system as a boost system. So I have the diesel engine running on the small diesel engine running on low energy,
Okay.
avoiding too much use of fuel. And when I need the peak power, the software in this little box automatically starts the electric motor, and the horsepowers of both of them peak up and allow you to use the system for a heavy application for a certain period of time.
Can we go backwards a little bit in time? I do have a question for you. You talked about, let's say we've got a diesel motor that's pumping out 400 horsepower. That diesel motor doesn't need all 400 horsepower 24/7. It may only need a small portion of it. And you guys, with this hybrid motor, whether you're hybrid to gas, you're hybrid to diesel, basically what you're doing is you've created a software system that determines how much horsepower is needed at the moment, and then will allocate the power from whether it takes it from the diesel end of it, the electric end of it, or both. Is that correct?
That is correct, and I could have put it better said.
Okay, well, I got one thing right.
And to that extent, the requirement, like you have the opportunity here again to switch between the two, let's call them prime movers, from the diesel engine in this case to the electric motor. So Michael explained the clutch, and the clutch is exactly as he said already. You can switch on and switch off the either or prime mover. And coming, one last comment from my side, and then Michael takes over and probably talks about the scalability. Modularity, you had it from the beginning. This kind of concept is available for a 1.2, 19 kW, 26 horses, somewhere around 70 Newton meters, the bigger brother 1.7, all the way up to its big brother 3.6 at the front end, where you end up with 540 Newton meters just from the prime mover.
So it's modular and it's scalable. Yeah, depending again on your use case, whatever you need out there, we should have an answer for that.
And the guys that are watching right now, and we're going to get into this, you guys have developed an app that allows them to sit at home in their underwear, eating their Cheetos, and figure out what is the absolute best motor application for what they are doing on their own job sites, in their own equipment. They can take that and go, oh, it'll fit, it won't fit, it'll work, it won't work. And you guys, this app that we're going to be looking at,
the configurator has the ability to speak to all the nuances which are required to build up your user story. And foremost, it is that the user really remembers and realizes what are the influence factors of your user story. So it's not that you just configure to one situation. It is really that we are helping to support you building that idea around your, in this case, customer user story.
okay, so do we have more to look at with the hybrid system, or are we?
Should we walk over to the lithium-ion battery?
Yeah, let's go. Let's look at the next one. So we're going to now look at pure battery powered and what that actually means. And then we're going to ask him a few questions about batteries, toxicity to the environment, renewable resources, things like that. The viable options of, there's a lot of questions out there. Well, batteries are great, but what happens when you got to throw them away? Then they go into the you know what I mean? How do they manage transmission? How do they manage transmission on each product given the modularity of the engine?
How do you manage transmission of power?
Yeah, I guess all the question was, how do they manage the transmission? As electric motors kick out a ton of torque compared to a combustion engine.
Indeed, that's a very good point.
Okay.
In fact, we would have to calculate. And in a situation where the torque and the RPM of the motor and of the engine fit together, the system that we have looked at over there, the hybrid system, will work as it's scaled up. So the area work platform we intended it to be used for, it'll work. There might be situations where the high torque and the high RPM of the motor actually needs to be reduced, and because we're Deutz, we are actually doing our own gearboxes in-house. So we have in-house engineers, bright young people that develop our own gearboxes, and those gearboxes would be put in front of the motor, would be attached to the motor. They would reduce they would reduce the RPM, and that would be depending on your application again.
Fishfine 3000 wants to know if these batteries can be rebuilt.
Can be rebuilt in terms, you mean if this is for an application and the useful life of the battery is over, because it doesn't charge enough anymore. Yep. This battery can go into a different application again. It could be used as a stationary system for, for your home, for my home, could go in my basement. It could take the power from the solar collectors on my roof, could store that for the evening where I put my electric car in the garage, and then I charge my car with the power that is stored in this battery.
So one of the things too that you guys now are redoing is you're not just throwing these away and then all of the chemicals are leaching down into the water supply. You guys are actually, go ahead, I'm sorry.
The stuff in the cells, the lithium, other chemicals that are in there. What we know today is this stuff is scarce, it's difficult to get, and it's expensive.
Yeah.
And there are methods in place today to take, once the lifetime of these cells is really over, they can't be used for anything else anymore. There's actually companies now, you can Google them out, that take those batteries and they disassemble them, and they have processes to get the chemicals back out, to clean the chemicals and to bring those chemicals back into the life cycle of building new cells, building new batteries.
Okay.
Which is, I think, the great thing, because those chemicals have to be treated carefully, but there's a cycle now. Yeah, it's not a loose end thing where it ends up somewhere, I don't know, in a dirt ditch or something like that. There's a cycle now, and actually the chemicals in the cells are being looked at and are being recycled for further use.
Okay, so you've got to talk a little bit louder, Michael. The guys are saying that the volume. Yep. Okay, so what did you want to actually show us with this system? Was there anything that we've already missed, or did we cover it?
I would definitely ask you, Michael, for scalability, but would you be interested to show Stan in the audience to do that at the super compact telescopic loader, which you fully electrified here together with JLG? Would that be something?
We'll go there.
Let's
Give
go
me
over
1
there.
second. I think one point I wanted to make here is this shows this battery is in production and it's being delivered today. So the key thing here is Deutz today has the capability to engineer, to produce and to deliver lithium-ion batteries. Yeah, we're in that market. We entered that market. We're in that market now. It took us 3 years. And we're there. And if you look at the display, what you see here is it's actually a two-layer display with you see those 3 black boxes.
Yep.
Those are so-called modules. There are another 4 modules in the second layer which we can't see.
Okay.
And those modules are where the cells are in, the actual battery cells are in.
Okay.
Now, what you can easily imagine is I could build another level, put another 4 of those modules onto this or below this, and I have a battery that is a bit bigger in size, but has a lot more capacity. So we're able to scale this baby. Again, depending on the use case, depending on the vehicle, your application, we can build different sizes of batteries. We would have the same software in there. Again, software is ours. Deutz does the software for the battery. Yeah, so software is there. Battery management system is there. Scalability is a question to the customer.
And scalability, we're going to go look. So when we talk about scalability, can you actually tell me, break it down? What do you mean when you say scalability?
Scalability means this is, in this one are 7 modules.
Yep.
And the kilowatt hours are 35
Okay.
gross. Gross kilowatt hours, 35, 7 modules. We're now going to look at a black case, which is another battery.
Okay.
In this vehicle, there is a lithium-ion battery. It's made of the same modules, but in this battery are actually 8 of those modules.
Okay. Same modules. All you've done is stack them up.
There's 7 over here 8, because it fits into this machine. I'll get to that in a second. And now this application, or this battery, has 42, not 35, yeah, but 42 kWh, kilowatt hours. The space we had to build it in allowed us to put a module more in, and we did, because obviously more kWh means more mileage or more hours of use. Yeah,
Okay.
the customer likes that. Obviously, the customer wants the vehicle to be run as long as possible.
So there was a question came up, where are you actually getting the fuel cell technology from for the batteries? And how do they handle extreme temperature, and is there a reduction in life and output?
Battery cell, not fuel cell.
Oh, yeah, battery cell, I'm sorry.
The battery cell, the modules themselves, we are buying from the market, and there's different sources. Yeah, some are in Europe, some are in Asia. It's a growing market, it's a big market, and we're looking that we have different streams of product coming in, and we're looking at specifically having safe modules in. That's a key thing with lithium-ion batteries. You want to have you want to understand how your supplier is actually manufacturing those modules, because you want those to be safe and you want those to last for as long as possible until they alter and until their charging doesn't work.
And how are they holding up in extreme temperatures?
Now, in extreme temperatures, which in this case would be below -5 Celsius
Okay.
and above roughly 45 Celsius, these cells or the software of the cells, the software that we built, would actually shut the battery off. Because outside the temperature range between -5 Celsius and 42, the alteration, obviously that wouldn't be good, because this product might be out there in the field at 0 Fahrenheit, at -10 Celsius or whatsoever, and the customer will say, hey, I want to use it. So what we do is, we actually have, you see a lot of piping here, the black stuff. What we actually can do is, we can manage the temperature of the battery, because we have cooling. In this case, actually, we have a cooling system in here, and we could have an application that also has a heating system in it. So if the customer says, I have a situation where from, you said, Bordeaux to Patagonia, somewhere is going to be is a desert, and somewhere in there it's going to be rather cold.
Yep.
Will be, if the customer says, I need to span the whole area, I need to do -10 Celsius and 50 Celsius, then we'll put a temperature conditioning system in.
Okay.
And the battery will be
So you have systems in place that allow even pure battery technology to go into applications where it may not be optimum
yes.
temperature range for the battery, but you can continue to work outside of the optimum temperature range.
Management allows the battery to be used in, as far as we know, any thinkable condition. Exactly.
Okay.
maybe
Depends on the use case, depends on the interaction with the customer.
And exactly
Perfect.
on that use case, Michael, we should add here that our customer JAG is with us together in this concept study to exactly do the investigation of that use case, because it is so multidimensional. I think that is very important to say of that concept.
What we're doing here, and thanks for pointing that out, what we're doing here is, with the customer, what did we do? We took the customer's vehicle, produced in the USA. We took it, in this case, we took it to Germany, took the diesel engine out, put our system in, put the fully electric system in, and if you close this, which has not been changed from the original vehicle, it fits.
So this is the original design.
This is the original vehicle design. We retrofit it, and now we have it here to show it to our customers, and those customers will feed back what they think of it. It's going to be out there in the field. They'll look at it. They'll test it.
So let's
We're going to get feedback from them to optimize the system.
So this brings us to the modular design of your engines. What you guys have done is you've created an app that allows a guy to say, hey, I'm going to have this telehandler. I want pure battery. He can go on an app. He can create a pure battery powered or electric motor. It'll fit right in there. He can go with a hybrid motor. It'll fit right in. He could go gas, diesel. It will fit right in. And that's what you guys have done. Instead of having, and one of the other things, instead of having like a different motor for everything that's out there, you guys have created almost like a universal motor.
In solution state, it's what it's called. And that's where the European content or the headquarter content has such a big value, with that added value for our, in this specific, the US American customer base. It's really a drop-in solution. But what does it mean for you as an OEM? You have nearly no engineering hours on your side, because as Michael said, you take the mechanical architecture of that vehicle, apply this very efficient new technology to it, and now you're back in a totally different user story of your end customer. Absolutely correct.
Okay, how about if you leave this thing sitting outside overnight, 0 degrees Celsius? Is the battery going to discharge on its own, or will it hold its own temperature, or what do you got to do to make sure that you got something operating in the morning?
It's going to hold its charge. That's no doubt on that.
Will Tesla's discharge
Over time,
if left in the cold?
Then let me take that back. If you let this thing sit for 6 months, somewhere where it's really cold, you're going to see a discharge. The discharge is going to be in the, I don't know, in 1-2% per month or something like that on the state of.
Oh, really? So it'll actually hold its charge that long, that well? Okay, I didn't know. All I'd known is I got a couple buddies that own Teslas, and they're always talking about in Minnesota they can't leave them out. They'll discharge if they're gone for a couple weeks. They'll come back. They won't have a car that's operating, and that's where that question came from. That was one of the guys asked that. and I was just sharing my, limited experience with battery discharging.
What the battery does is, if the battery itself is cold,
Yep.
it loses mileage. Yeah? So the charge is still there, but you can't use as much of it as you would if it's in its perfect temperature. That's why temperature conditioning can be important. Yeah? So what we would suggest is, if you are in a situation where your vehicle sits out or your application sits outside, it gets really cold at night, then plug it in, and then we use the grid power to heat the battery up in the morning, yeah, to have it in perfect condition when you start up the vehicle. Or if you can't do that, then when you start up the vehicle is going to run on, I don't know, lower speed or whatever, lower power for the first hour or something like that, until the battery is heated up again and until you can use full power.
Okay. Let's talk about the cycle, the life cycle of the batteries themselves. So we said that the batteries will last about 2,000 cycles. And then what happens at 2,000 cycles is these guys have to throw their batteries away?
Explain the 2,000 cycles with the state of charges, please.
Yes, and again, important point. Again, it totally depends on the use case. Yeah? It can be 3,000 cycles. If your use case is a very smooth one, yeah, there's no, I don't know, harsh peak power situations on your application, yeah, then you might even go 3,000 cycles or so. If you have an application that charges and discharges the battery every day at full power, yeah, then it might be only 2,000. 2,000 is what we think
condition.
Yeah, is the worst case condition. Thank you for our product here. The alteration is something that we can't stop, at least at this point in time. Chemistry, the chemists have not found a way to stop the chemicals in the battery, in the cells, not to alterate. That means if I charge and discharge this battery over 2,000 cycles, it will lose some of its ability to hold power, to hold energy.
To hold energy, not power.
Thank you.
All right, so basically what that means, you guys, is that you guys are going to experience this, you guys are going to hear this, that the life cycle of a battery will drop down to, and I'm not talking about you guys, I'm just talking about what I've understood it, is that it's got 2,000 cycles, and then at 2,000 cycles, it'll drop down to producing 80% output, meaning it'll still produce 100% power, but it'll have less, your fuel tank will be less, so to speak. You may have 100% power for 8 hours instead of 100% power for 10 hours per day. Did I explain that right?
You did that perfectly.
Okay.
Yeah.
Okay, good. Then I got it.
We put excess capacity in there to make sure that over the cycles and over the years, when you lose capacity, when you lose the ability to hold energy,
Yep.
that excess capacity starts to be used and used and used, so that you don't experience a gradual decline of mileage or hours of usage or so,
Okay.
but that stays the same. And at some point in time, again, 2,000, 6 years, 7 years, whatsoever, 2,000 cycles, 6 years, 7 years, or whatever, you'll start to feel it. Yeah? And then still the question is, are you okay with 80%? Or are you going to say, let's replace the battery, let's reuse the battery again, yeah, at home or for some stationary application, or let's put it into dismantling, recycling, and bring another battery back to life.
Okay. What else do we got to cover on battery technology, you guys?
I think, Michael, how about talking quickly about the space volume, about the scalability on this specific example, because we do have a super compact G518A is that application, and you can say we picked together with JLG this kind of application because it has the multitude of user story, but it is for Michael one of the challenging applications to fit it all in and make it maybe Michael, the serious production content, our ability on it, the scalability of these kind of modules which we have in front of us. You touched base on them. with the 7 modules over there, the 8 modules over here, but sizing. Could you maybe just comment on the sizing and what is included? It's not only the it is not only the modules, it is the BMS, and that is what the full package is. So that's maybe something, a couple of sentences worth to talk about.
Yeah. Okay. If you have, if there is no room, we can, as we explained earlier, or we talked about earlier, we can put more modules in. Yeah. The software, the management system for the battery stays the same. Depends on the room we have, yeah, and depends on how much storage do you want to have in there. Again, discussion with the customer. Yeah. How much do you want? How much is possible? How much do you want to pay for?
And I want to pick up on that. How much room do we have? Sometimes it's not only the room just in a size. It is really the nuances of the envelope, and we see that nowadays with the Teslas, and we see it with the current tank shapes. So we have so many different forms and shapes of the tank, where Michael and his team is capable to fit, form and shape these kind of modulars in the kind of shape which we need for the user story. We use that word very often, but it is all depending on the usage and then even of the architecture which allows us to implement these systems.
So now a couple times you guys have talked about fitting, shaping, configuring. Are we getting to that point where we can take a look at the app yet? Have we gotten that, or are we missing it? I don't want to make sure we don't miss anything.
Call Marco in that for that topic.
All right, so we've got Marco and Matthias, and you guys have an app. This app is the service end of it. It's the main. It's the. Can you guys just tell it instead of me, because I don't know?
It's a digital solution of all you have heard already here. And one is the configurator that covers all the modularity you have seen on the engine side.
Okay.
How to handle it, how to configure engines, which are then applied to the application. And the second tool we want to introduce you is the service tool. It's also a digital tool which covers everything about service.
Okay, so wait, let me introduce the guys before we just start talking. Marco, can you tell us what you do for these guys?
Okay, my name is Marco, and I'm responsible for the product management at Deutz AG, and also for the digitalization of service parts and tools.
Okay, and Matthias?
I'm head of central sales, which is all the departments of Marco and some others. And we care now about how we digitalize all these actions that we have in combustion, in electric engines, and how we bring it to the market, to the people, and into the field, that everybody from Australia to Alaska knows what to do, from electric engines to up to diesel engines.
So one of the things that you just said that I don't want to skim over is that a guy that's in Timbuktu is going to get the exact same service as the guy that's right in your very backyard, right next to the heart of your service center. You guys have created this app to make sure that the service that these guys, when they buy a Deutz engine, Deutz motor, whatever you guys want to call it, when they get into the Deutz family, they're getting the same service far out in the field as they are right in their own heart backyard.
That is the McDonald's formula, to say like this. Everybody knows what to receive and what to buy, and we want to be at the same level of responsibility and product usability. That's why our full support is also not seen only in the technology, it's in the field, in the service. And if you don't mind, we want to show you 2 applications right now.
I was going to ask you guys, I don't want you to explain it. I want you to actually show us how you actually are implementing it, because everything is great in theory. I mean, hell, I'm 6'2" and I look like Aquaman in theory, but in real life I'm 5'11" and I'm old and balding. So let's get to the real nuts and bolts of how you guys make this happen. So let's take a look at this.
So maybe first, I recommend that we start with the configurator, because we had a lot of choices before. You can burn everything, diesel, gas, hydrogen, you can use electric power, but how we make it easy for our customers to select only one square meter, and to say you have to put everything in, either diesel or hydrogen. That was what Marco present in the advanced configurator, and then I will present our service live repair, where we really want to enhance all the service in the field.
Okay, so Marco, you're going to walk us through how these guys can spec out almost any engine into any piece of equipment and know if it'll work or not.
Okay, you have heard a lot about the modularity, and one can ask how can we handle it, how can we configure it, how can we use it in the end. So what we developed is a configurator where you have 4 steps, and in these 4 steps, with these 4 steps, you can configure your engine.
Okay.
So you start with the emission area where you want to go with the engine, and we take your Americas.
Okay, but wait a minute. That's an important step. Because
Yes.
every country has different regulations, and you
Yes.
guys got to match all those, right?
Yes, because this is important. This is important because we have different emission regulations in the world. We have Tier 4 final US, EU Stage 5 in Europe, and China 3 coming up, China 4. And this is very important to start with the right target country.
Okay.
So then we take the US here now. Here you can see the Tier 4 final emission legislation right now. And then we would go to the application. This is construction.
So can you back that up one? Because I saw farm equipment.
Hold on a second.
Or am I messing you up, Marco?
No, you don't.
So you have agricultural equipment, material handling,
Stationary equipment, marine,
ground support.
and ground support equipment, and also railways.
The reason I point that out is because one of the questions earlier was, where is this application at? So I want to make sure these guys know that these applications fit all these categories. And I know
Yes.
we said it, but now we can actually see it. Okay,
You
go
can
ahead.
see it. These segments are all the segments we are supplying with our engines.
Okay,
Okay, so we choose construction equipment right there.
Got it.
It's excavators and all these engine applications. Then we choose the power output. It's here right now 56 kW.
that's 74 horsepower for guys that
Yes,
want to know.
it is. Then we submit. And then we can choose here what you've seen: diesel, gas, full electric, hybrid, or a hydrogen solution. So if you go into diesel, you get a suggestion. And due to the emission stage we choose and the power output, they suggest from our portfolio the 2.9 diesel engine here.
Okay,
Okay? And then you can go into the configuration and you can go into more detail. This is the difference between only having a catalog of engines. This is what makes a configurator.
okay.
Okay, so you can
use. So you can choose also options like in the automobile industry where you select several leather or whatever. The same thing we transmitted here, and to make it easy also for a mechanical.
What are you talking about?
Yeah, then you can select radiators or whatever. So you can decide if you want to do it on your own because you define it as a crucial part of JLG, for example, or you say no. I could think about it to give it also in the hands of Deutz to have the full warranty, the full system directly integrated.
Okay.
And that's what we discuss here with several options where you can exactly define and configure to your personal needs what you need in your industry to really compete in your market.
So let's say that I'm sitting at home and I configure this engine, and then I can go to my JLG dealer and say, this is what I want, I know it'll work, and these guys can put it in?
Even as end customer you could, but for sure JLG would wish also to have some standardization and not to allow every singular modification. But at least we could offer it. So, but for sure we are interested with the OEMs to make a standard overall, because you can imagine if every single person define its perfect engine, then you have 3,000 types every day outside. So it's more for the OEM, but even good dealers or good final customers could do it.
Okay, got it.
So okay, if we have some options here with module 1, it's the AT. Is it loose or is it mounted on the engine? Then we have the oil pan. We take the normal one. We have different ones. The compressor you can choose. It's an alternator.
Some examples here.
Some examples. It's predefined in order to get fast to the track. Okay.
So this app not only helps you pick out what is the right motor initially, but this is also the same app that is going to help these guys with their service. And this is where it turns, to me, what you're seeing behind, and we're going to get to that, is magical. And I know that sounds kind of weird, but honestly, this is We're going to get to that. So you guys make sure you stick around. It gets better. Trust
Okay.
me. And this isn't bad. I'm just saying that is amazing. That. Okay, sorry.
So, in the end, just to go a little bit faster to see what it ends up.
You don't have to go faster. I want to understand this.
Yeah.
So don't
Okay,
breeze over.
you have a couple of options regarding fuel and flywheel for the more technical ones, and then it configures the engine due to you select the parts you selected and the engine you selected at the
So
beginning.
this is really putting the ultimate control of what these guys are getting in their own hands.
In their own hands, yes.
Okay, got
That is
it.
everything what you had in the video before, where you took 1 hour to select all the information. Here we have in the product description and also 3D
Models.
cut design. So you can directly, JLG for example, or other brands, can squeeze out then exactly the engine. Marco will show an example. And they can directly check if it easily fits in their application or if they have to change something.
Got it. That makes
We want
sense.
to make it as easy as possible that nobody has to change anything.
Okay. Okay. So now we've got our engine designed. Where do we go from here?
So you have 3 tasks you can fulfill. You can show. You can look at the sheet. What you have selected here.
Okay.
Okay. The product description, and then if you are interested in this engine and you want to have an offer regarding pricing, then you send an email
Okay.
out to the sales guy, and he gets into contact with you and discussing all the pricing.
With all the detail, he
With
has
all the
not
details?
come through all the mechanical issues again, which is also a critical part because I think today every engineer has to repeat his story every day. So here it's directly transmitted, and we know it from Germany to Norcross and back again.
So now we've designed our engine, but we alluded to the fact that a guy can get a warranty that goes forever and ever and ever. As long as he owns the unit, he's got a warranty. Can you start to take us through the serviceability, how this
Live warranty.
this app, this same app is part of the serviceability of the motor, which is also part of the warranty, and that's something you're rolling out. It's not there yet, but you are rolling it out. Okay?
So first, the last thing is the 3D.
The
Okay.
3D model, you can receive the 3D model, and this is very helpful for the OEMs that are using our engines, so they can look at the 3D models and look how this will fit in their application with all the interfaces and all this stuff. So this is a value add for them. Configuring an engine using the 3D CAD model to put it in their application and see how it ends up.
So now let's assume a customer like G&G, like the configurator, they found a new configuration, it fits, and then they are selling 10,000 pieces of it, which makes us happy as well. And then the field service from Australia to Alaska is quite important. Then we have to reflect, do everybody has subsidiaries everywhere? No. Do we ever have everywhere mechanics? No. Does we have a man in the van everywhere? No. So we really have to reflect the different situations in different countries, different languages. And to be honest, today we are doing everything via Amazon, Google, Alexa. But in the old business we are quite old. That's why we said we have to do it in a new design like Alexa, Amazon, Google, and we have to do it in easy steps as in Facebook. That even a non-engineer, I'm not an engineer, I'm a commercial guy, could repair an engine without knowing anything because it's live trained and live augmented when he's repaired.
That was a very interesting point. So as we look at the next phase of this app, when you say it will actually help guys repair their engines, can you kind of start to walk me through what that actually means?
Yeah, for example then, we have the selected engine, so we type in the engine number and you obtain exactly the engine that you have in your application, not another one. You can see it's now with the VLAN here a little bit slow, but you can go through 360 degrees, so you can play everywhere, what you cannot do with an engine implemented in the vehicle, so you know everything. And the interesting thing is, for example, end customers. If you have in Alaska an end customer that is maybe looking on your video, and there's no dealer, nobody, we can allow him to have an entrance as well. If JLG says there are some rental fleets, for example, repairing themselves, we can allow them to have an entrance to the tool to repair themselves. Or we give the allowance to mechanics that we employ, or subsidiaries, or men in the van. And we can do all of them. That's why we have certain levels of repair allowance. And for example, here you see that engine, and if we have some crucial parts changed, or we have some repair, some warranty issues, then we indicate it directly. So you have a first entrance, please check the flywheel, please check the radiator, there's something.
So I need to jump in here because what I want these guys to understand right now is when they use this app to configure their engine, and it goes into this app, and they have a problem down the road, because everything breaks eventually, when they have a problem down the road and a technician comes out, the technician is going to go into this app and actually see their motor, not a generic motor. Their actual motor is going to be right here, the one that they designed, with all of the service history, everything that's ever been done to it in a 3D exploded model so that the technician can do it. And what you said is as the technician comes out into the field, we're McDonaldizing this whole service approach. The technician is going to know how much to screw in the screws. It's every little nuance is right here to make sure that everybody across the globe is getting the problem-free, right? Problem-free service.
Exactly. So what you're saying is you have typical repair steps, you have typical maintenance steps. Here you see separate points for individual repair situations. So with Deutz, it's depending on hours, running hours. If you're converted from a passenger car business, it's 30,000 or 60,000 kilometers repair. So here we have several steps, and you are scanning the new products that we put in. So if the air filter was defect, we know where it has been put in. So we can make an easy recall without damaging anything.
So when you actually say that, one of the things I want to point out is if something changes, a guy buys this engine and 3 years down the road, there's something happens, you actually notify the end user and say, hey, we need you to make this modification. And then that's how they, as long as they follow the service recommendations,
then they will also be within the long life warranty that you explained before. So that is now the tool of life repair, where we really enable the field to McDonaldizing the world in Alexa style, to say like this.
Yep.
And the next step will be a telemetry system, what is also now tested by Marco's department on our test bench. So we are provoking typical failures, injector failures or whatever. So we need to see which error codes we are sending, because we want to send you on your iPhone. This is happening to your engine. Please stop shortly. This would be 1 hour repair. Can we come out? And if you say yes, then you give us the order to come out, and you know exactly what will be the costs.
I need to stop you right there because I want these guys to understand what that means. You're running your JLG. It seems fine. It says, wait, whoa, I'm starting to sense that there may be a problem in the whatever. And it sends a code to the app. You guys contact the end user and say, we've noticed that there may be a problem with this code. Is it okay if we come out and get that repaired? And as long as they allow you guys to do the proper maintenance, the proper service, you're going to continue to give a warranty. You're not going to end that warranty.
Exactly, and it's even a little bit more complex. The information will go to the end user. It will go to Deutz network. It will go to GLG network in your example. So even the GLG subsidiaries will be informed, and we can define with GLG the rules. So maybe in America, JLG will say, it's me that is going out, and we engage him to be fast via digital solution. Maybe in Germany he says, Deutz is so strong, I will let that be done by Deutz subsidiaries. So we are going with the name of JLG out. The point is we want to service fast. And if there's somebody in Alaska having a bigger fleet, and JLG and Deutz say, we allow him to enter with some levels to the system.
Yep.
He is allowed to repair up to a certain level. And those levels we have here, for example, in repair, if you take a new one, a commercial guy like me, so you you are led through job card description, every detail, and you have to go through and click, and then you know the work has been done. If you go to a professional, he will get angry. He only wants to see. Wait a second. He only wants to see the details and touch somewhere. Marco, can you do it?
Hold on a second.
Okay, so one of the things that I think this is really important, because it doesn't matter if it's a single owner operator, you offer the same service, the same everything to them as you do to the guy that's buying a fleet. It doesn't matter. You're not giving better service to one guy because he buys 10,000 units than you are to the guy that buys one single Deutz
All
motor.
of them want to go out, earn money,
Engine.
and make some work. So it has to be done. The engine has to run, the motor has to run, and the GLG hydraulics has to run. So everything has to be in good shape. Otherwise, it won't work. And that's why we have all this tooling. And you say some important point. We have to rethink every single situation. That was the work of the department. It's only the 2.9 family in now here. The rest will be done this year. But only a 2.9 engine has 2 million options of information. So he had to combine 2 million options in the view on the OEM, in the view of a fleet owner, in the view of an end customer who only runs one application.
Okay, so one of the questions came in, who has access to those codes? Who's allowed to repair those codes and stay within the warranty guidelines?
That we define, for example, with JLG, depending on their network density.
That's just one, because you guys are in a lot of different applications. You're not just in JLG. We're just using it because that happens to be in your booth.
But we have to define with them together who has to go out first. So if you ask me personally, I want to have something like a 6 hours. We are together with our customers out there within 6 hours and ensure to get back to uptime and reduce downtime. We are coming from the truck business, there it's quite standard, so we want to bring that here in this industry as well. So and then we have to define with the fleet owner on how we do it, with the brand on how we do it, because it's a common way. You cannot do everything on your own. But the important thing is the communication between mechanic, subsidiary, OEM, customer, and the user. If you keep the user stupid, for example, if you take a normal car and you have a red lamp, you don't know what to do at all.
So if the engine light goes off, he has no clue. It's just like, there's an engine
If
light.
you're running to the subsidiary, it's your fault. The warranty will blow you up. And if you stay there, you have a car highly paid, but you don't know what to do. You have to pay to get to the subsidiary. It's quite stupid. We don't want to give you a red lamp. We want to give you a clear indication what to be done. And even if the customer says, I want to select if I can do it,
Yep.
or the subsidiary will do it, or a dealer, finally, I don't care, as long as it's within 6 hours and before we allow the people to have the contact to the system.
So you're telling me that the owner of the piece of equipment can repair it as long as he follows the guidelines that you guys have set forward.
To
And
enable some people for sure. It won't be everybody in the system for sure, but it can be, for example, of America, of my colleagues, a program where he enables not only his subsidiaries, not only other partners, also fleet or smaller owners to repair themselves a certain way. For sure, when it comes to warranty, we will include our people. Because if you make failures there with 6 hours claim, you won't succeed.
now you keep saying 6 hour. What you're trying to say is then your goal is to make sure that if you have a failure inside of a Deutz component, you have the guys operational within 6 hours again?
Yeah, that would be my task in future. And that's a task, not tomorrow, but we want to do it within 2 years for all the engines. And you can imagine, coming from the hydrogen, who is brand new, the electric components that are brand new. So it's a huge work for his department to make the digital information being ready to do such crucial steps.
And there comes the telematics into place. In order to get that far to predict failures and all this stuff and to ensure 6 hours uptime, there you need telematics as a system that sends you information, and then you interpret this information and get out to the customer.
And there are a lot of people having already telematics, so we are working for an open one. You can buy it either at Deutz or you can take your own one. It only has to communicate the same failure rate, and it's via cloud-to-cloud communication.
So Telemetrics, just to really briefly explain that, because I don't want to lose any of these guys on any one of these components. I mean, they're spending on a brand new piece of equipment, they're spending anywhere from 50 to 250,000 upwards, dollars, whatever they happen to be buying. I want these guys to have a very clear understanding. What are you guys referring to when you say Telemetrics?
Telemetrics is a box what we put in that helps us to indicate failures before, to send to your, for example, to your cell phone. There is a general maintenance in 2 weeks. Do you want to come in and book already now? If you want to go in rental fleets and you say, you enter, I have a customer with 30 days interest, we can announce you, but in 15 days you have a special repair because we see there is a problem somewhere. So before renting now for 30 days and coming then on the 15th day in, because an injector is not running well, we will do it before or indicate the rental fleet, don't rent this one. If you don't want to repair, rent this one because it's already repaired. So we really are looking on uptime, and the Telemetrics is only a crucial box that sent us 528 failure codes, and it's now the topic of Marco, not to...
No pressure. No pressure, Marco. 2,100 million parts in every single motor, dozens of different motors, no pressure. Come on, Marco, let's get to it. And you can have it done by Wednesday of next week, right?
That's what I'm saying, he takes it straight. But the topic is now not to send to the end user failure codes, but because what can you do? What can you do? We have to send them the solution and the price recommendation, and this is the basis of this tool.
And now you can go so deep as you can ghost this engine.
Yes.
So what you've actually done right here is you've actually gone, let's say that you have a problem internally, you can actually see what's going on inside of that in a three-dimensional, rotated around kind of like a format. Is that right?
That's right.
Yeah, you can. I don't know if it works here with you can
the VLAN
look
here.
You can look all the 360 degrees. From the top, from the bottom,
and then it'll tell you every one of these tags.
There's danger. There's a danger, a warning that it's a hot part. So don't touch it, and be careful.
And it'll tell you how much to tighten it. So it'll help a service technician that's out in the field that has maybe not as much experience as a guy that's been doing it for 30 years. It will tell them how much to tighten up a torque nut, what to do, and the guy that's been out in the field for 30 years, he can skip past those steps and
only go to a screw and ask himself how many newton meters he needs to torque. And this is the first tool now, making live repair easy, self-trained, logic and clear.
Okay.
And also have a scanning part that you scan our parts, and we know exactly which parts have been integrated during a service. So if we have a recall or only seeing discount discussions with customers, we know everything, which is great for everybody. Then the second thing will be the telemetry, what is Marco now building up. And then if we have a monitoring that is so predictive, so in front of advance to every situation that you can have in repair, maintenance and breakdown, then we are keen to give the long life warranty to say as long as you follow our and the OEM rules that we will also gain for this method, as long as we have no problems to grant you long life warranty. If it's 5 years, 10 years, 15 years, because there are clear steps how to follow, and as long as you do, we have to commit something, and then our target is to make warranty something positive and nothing about a negative claim or whatever.
Perfect. Where do we go from here, guys? Have we covered everything that we wanted to cover inside of the booth? I want to make sure we haven't missed anything because I know we're covering a lot of ground, but there's guys that are going to be spending a lot of money based off some of the stuff that they learned in this video, and I don't want to skip over anything.
I think you have seen a lot of technical details. You have seen digital things. Maybe we make a recap by Mr. Daniel, which is the board member of sales and marketing. So a lot of things that we are doing at the moment is also based on his pressure, not only on mine.
Okay.
So maybe we take the time to get him out of the customer discussion.
Okay.
And say some few words on where he wants to have Deutz in the future.
And what are we looking at, Bob? I want to introduce you guys to Bob. Bob's in the background pointing, and actually, Bob.
Let's just have a few words about the remanufacturing process.
Oh, I had no clue about. All right, so Bob, can you tell us what you do for Deutz?
I'm the president and CEO of Deutz Corporation in Atlanta, and I'm responsible for operations in North and South America.
Okay, so we haven't touched at all on the
Reman.
on the reman. So
Yep.
this is
This
all
is
right.
an example of basically a show example of a remanufactured engine. We've shown effectively
I need you to talk a little louder.
Effectively, the front half is or the back half is remanufactured. The front half is not.
Okay.
But we remanufacture our products either in southern Germany, in Ulm, or in Pendergrass, Georgia, and we use a 300-point remanufacturing process
Okay.
where we take the existing components of the engine, block, cylinder head, crankshafts, camshafts, connecting rods, all the other kinds of parts, flywheels and castings. And we make sure they are within original specifications, in original tolerance.
Wasn't that what everybody does when they remanufacture an engine?
No.
I don't know. I mean,
You don't rebuild engines,
okay.
but remanufacturing them, you really need the existing original drawing.
Okay.
You can say, okay, I can skim the block 10,000ths of an inch, and I'm still within the original specification.
The original tolerance. What happens if you fall outside of those tolerances?
Scrap the part, move on.
So that are there engines you can't rebuild?
Absolutely.
Oh.
And you get some you can put your head through the hole in the block occasionally too, which are very old ones.
Okay.
Yeah.
So is it almost safe to say that when you're done remanufacturing, you call this remanufacturing, not rebuilding?
No, sir.
Okay.
We're not swapping, looking at a part and going, yeah, maybe.
So is it almost safe to say that it's as good as a brand new engine?
Exactly, and we give it the same warranty as the brand new.
Okay, so now I got a really interesting question. If you're willing to give it the same warranty as the brand new engine, is that included in the new app, the new service you're coming out where after you have an engine remanufactured, you could almost literally just run it forever as long as you follow the guidelines in that app?
Probably in the initial steps not, because really what we're remanufacturing on average can be 10 plus years old.
Yep.
Sometimes back 25 years old.
Okay.
So these are the kind of products we're dealing with. We still use, of course, the original documentation. So the chance of documenting those very old engines in a new app
Okay.
is probably not the most optimal thing first. Otherwise, poor old Marco will be working till he's about 106 to get it done.
Well, he looks young enough. He can get it
He can
done.
handle it.
Yep.
But the engine's remanufactured to the to the original spec. So if an engine fails in a Vermeer machine, a Ditch Witch machine, by the serial number, we know exactly how that engine was built.
Okay.
We know the original test pattern on the engine, how long it was tested on the original engine. So we do the very same on the remanufactured engine.
So when you say the back half of
This
this,
is just a for instance engine.
okay, but why did you guys do this? I don't get it. What's
So
the
you
difference?
can see what we looked like on the front before we got to it. The dirt's all fell off it at this point, but originally speaking, this engine was all grotty and grimy, and this is the nice brand new one at the back. It was just a for instance.
So this is an actual what it'll look like.
This is what it will look like when you get it back.
So this is what it'll.
Hammer grey, however, it won't be red and silver.
Oh, okay. So what Bob's actually referring to is you can see some of the original and
So
then
the original engine.
and then you can see where they switch it over. That's what a guy can expect to get when they have it remanufactured by Deutz, not by Al's Garage Shop out of
You'll find
Naperville,
that
Illinois.
Genuine parts. The block may be oversized. The crank may be undersized. But you'll know that when you receive it. So the crank can be ground one size under, two sizes under. The block can be bored a size over.
To get them within the original specs. Okay, so you guys have a universal spec, and as the engine wears out, to get it back to universal specs, you got to stay within the tolerances, and sometimes that means boring the block out and do it using a smaller crank. But
They're honed to the correct finish so that they're emission compliant as well.
Okay.
Remember, we're taking an engine out of the field that may have been the classic Tier 3 engine,
Yeah.
and nobody wants one back that's smoking, whatever else. They expect it to be as their original new engine.
They don't have to make it Tier 4 compliant, do they?
You can exchange like for like or better. So you can take a Tier 3 engine and replace it with a Tier 3.
Tell me what a Tier 3 is real quick,
There
Bob.
are multiple stages of off-highway emission compliance. Stage 1, 2, 3, and 4.
What are they?
It's a difference in the level of particulates in the exhaust and the NOx that comes out of the exhaust.
Okay.
So the EPA mandated it in a downward level to the point where Tier 4, we need to use after treatment on the engine.
So then, is it more economical for a guy to remanufacture an engine or just buy a brand new one?
Now, the way to do it is to take your existing engine
Yep.
and have it remanufactured. That way it fits in the same hole, same space, same emission level, so you're not penalized.
Okay, but are they going to pay more?
And you get it on time.
What about money? These guys, all these guys want to know about
If
money.
the engine is still available, a remanufactured one can be a little bit more expensive because you've got instant delivery within a week or so delivery.
Okay.
If it's a new engine, we may wait 180 days for it to come from the factory on a manufacturing site.
So you're remanufacturing their engine, not giving them somebody else's.
No, how we do it is we bring in the core product. So they supply a core against a core charge.
Got it?
Same as any other remanufacturer. We then take that core, disassemble it, clean it, inspect it, and understand which parts can be reused.
Okay.
Machine the blocks, machine the cranks, cams, rods. We then put all those parts in stock.
Okay.
When somebody has, again, for instance, a Vermeer, a Ditch Witch, a JLG, it doesn't matter. We look at the spec of that engine,
Yeah.
and we then pull parts from our store,
Okay.
mix in new pistons, new fuel injection equipment, bring it together, and build it as we would a new engine, but from a mixture of new and remanufactured parts. So it wouldn't be their very same engine. It can be a mismatch or a mix and match of any number of engines, but all of the parts are inspected and within original specs.
Okay. And so what about downtime? One of the questions is what is the turnaround time for something like that?
Again, the famous economic question, it depends. Our typical lead time on many of your viewers will know the 2011 engine, the oil-cooled engine. It's our classic Tier 3.
Yeah.
Typical turnaround time on those can be 7 to 8 days.
Okay.
If the engine is more complex, in the form of, for instance, the Tier 3 version of this engine, for instance,
Yeah.
it may take us 12 to 14 days on that.
Okay.
Some specs of very high movement, so we know the classic aerial platform engines, we'll keep those in stock, and you can get those off the shelf.
Got it. Okay. Anything else we want to cover on the remanufacturing, not rebuilding?
Not rebuilding, it's remanufactured, original engine warranty.
Okay.
2 years, third year on the big heavy parts, crankshafts and crankcases.
Perfect. All right, Bob. Who are you going to introduce us to next?
Now to my colleague, Michael Bellenzone, who is our board member responsible for sales and service from Germany.
Hi, Michael. How are you doing?
I'm fine, yourself.
Good. Okay. I know Bob kind of explained, but can you tell me what you do, Michael?
I'm a member of the board.
Speak up.
I need to hear a little louder, Michael.
Okay, I'm a member of the board at Deutz AG.
Okay.
I'm responsible for sales, service, and marketing.
Okay.
And I hope you had a good insight into our company today.
Perfect. All right. So is there anything you think that we missed or we should cover a little bit more in depth?
I think what we wanted to highlight to you today is that we are playing in different area of technology to cover the needs of the future in terms of CO2 proposition, in terms of efficiency, in terms of new machine architecture. So you could see diesel, hydrogen, you could see gas, gasoline solution, and our electric and our hybrid drives. And in addition, I think that is very crucial for our businesses, that we have a world-class service concept, and this world-class service concept we try to develop and to improve with digital solution, with give you on-time responsive or a response in the field, that the downtime of a machine or equally not being down about over condition monitoring, that is key what we want to provide to our customers.
Perfect. Bob, will you hold that for me?
Certainly.
I'm going to jump in, watch your finger in front of the camera. All right, guys. I think we've covered pretty much everything that we could possibly cover. I got to meet with the engineering team. I got to meet with the North America, the German, the overseas engineering team. I got to look at hydrogen and finally understand it. There's so many things that I didn't know coming into this. I hope this helped you guys out as well. This has by far been the longest video I've ever posted, and I need to hear from you guys. What did you think? I wanted to go really deep with this. I wanted to have a very clear explanation and understanding of the processes, because as I was exploring this with this team, I realized that there was so much going on that I had no clue. I hope this video's helped you guys out. That's my next, I actually want to go a little bit deeper on understanding some of the real world applications of where you can find these motors. So I'm going to explore that off the camera with some of these guys, and then maybe bringing you a second part to this. I haven't decided whether that's going to happen or not until I hear back from you guys. What do you think? Comment down below. And that's our video for today. I think that the Deutz team did great. I think it was phenomenal being here. Big thanks for letting me come in and invade your booth like this for the last hour and a half. So that was awesome. Thanks, Michael.
Thank you for having you here, and hope we could contribute to support this knowledge about this technology.
All right. So far, the show is good.
Perfect. Thanks, guys. God bless. Go get them, you guys. We'll see you on the next one.